We're continuing with section 6.4 on logarithmic functions, and now we're on example 1 to convert exponential to logarithmic statements. So we've seen that we can write the log this way, but we can also write it in exponential form this way. They are equivalent. So let's practice that here. We want to be able to go back and forth very fluidly and that's what this is going to help us practice. So we're going to change an exponential, x equals a to the y. So we've got it. It's in this format, just flipped on either side of the equal sign. So this would be our x equals a to the y, just making a little note to ourselves there. We want to change it now to a log. So what's y? 8. Our exponent is 8. The exponent is equal to the log. What's the base? The base is 5 of that exponent of t. We just changed the exponent to a log. Okay, what's the exponent here? -2 equals the log. What's the base in that exponent? It's x of 12. And here, what's the exponent? X equals the log, what's the base? E of 10. Okay? In example 2, we're going to convert logs to exponents, back the other direction. Okay? So the base is 2, the exponent is y, and the argument is 21. The base is z, the exponent is 6, and the argument is 12. The base is 2, the exponent is a, and the argument is 10. All right, now we're to evaluate in example 3 the following. Now we kind of were doing this on the other page, right? We practiced this. So in other words, the result of this is a power. So the question is, what power? 3, I could write it like this. 3 to what power is 81, right? Base to the exponent that's missing here, I could just say that equals y and say, what is that, right? Base to what exponent gives me this? And one way to solve that would be to say, well, 81 is 3 to what power? Is it 3 to a power? It is 3 to the 4th, so we can clearly see the power is 4. So this result is 4, right? Our answer would be 4. Log base 3 of 81 is 4. Okay, let's try that again. Our base is 2. We're looking for y, and the argument is 1/8. Let's see if we can write it with the same base here. So 8 is 2 cubed, but it's 1 over 2 cubed, so let's move that to the numerator. So that's 2 to the -3, right? So our y would be -3. In other words, this is -3. 2 to the -3 gives me 1/8. All right. The base is 5. I'm looking for the exponent, and the result has to be 1. My argument is 1. Well, what do I raise 5 to? What power to get 1? Well, obviously that's 0, right? Okay. 2 to what power is 16? Well, 16 is 2 to the 4th, so y must be 4. So in other words, this is 4. We've evaluated that. 3 to what power is 9? You're probably able to do that now without all this analysis here. 4 to what power is 2? Maybe we'll write that one out. Let's see. So 4 to the y equals 2, right? So what would we have to do to get to raise 4 to what power to get 2? That would be the 1/2 power. It would be like taking the square root of 4. Okay, and 1/3 to what power is 27? Well, what would that be? So 1/3 to what power is 3 cubed? Right? 27 would be 3 cubed. And this would be 3 to the negative, what? Or 1/3 is 3 to the 3 to the negative 1 to the y equals 3 cubed. So we get negative y equals 3, so y equals negative 3, right? All right, and the last one we have, the base is the square root of 5, which I'm going to rewrite as 5 to the 1/2 power. We don't want to deal with radicals when we're dealing with logs here. So 5 to the 1/2 power, right? Or 5 to the 1/2 power, then raised to, what is y? The square root of 5 to the y equals 25. But the square root of 5 I'm writing like this, so now I have 5 to the 1/2 y equals 5 squared. All right, so in other words, 1/2 y has to equal 2. Multiply both sides by 2, and I get 4. So the log to the base square root of 5 of 25 is 4.